Welcome to SAT Math Skill Builder number 4. So we take a look at this first problem. It's a system of linear equations. And we're given the two equations and told that if the ordered pair xy is a solution to the system, what is the value of x minus y? So sorting through this problem, nowhere does it say solve the system. Nowhere does it say, hey, this is a system of linear equations, right? We're told that we have this solution to the system of equations, and then asked what's the value of x minus y. So nowhere does it say, hey, go solve this equation, the system, but in order to find the value of x minus y, we need to know what x and y are. So it's implied that we need to solve this. So here's our two equations, and we can see that I don't have opposite coefficients. So I'm going to have to multiply or scale up both of these equations. You can pick either x or y to eliminate. The process is going to be pretty much the same. I'm going to go ahead and multiply the first equation by -4 and the second equation by 5. So when we do that, we have negative 16x plus 20y equals 40. There's our new first equation. And then the second one, 25x minus 20y equals negative 40. So we add these two together. 9x. Now we have opposite coefficients on our y, so those are going to go to 0. They make a 0 pair because they're opposites. And then also, look, positive 40, negative 40 equals 0. So our x is going to be equal to 0. Awesome. So we know that we have 0, comma, and then some y. We're going to need to go ahead and substitute that value of x back into either of the equations. I'm just going to pick the first one. So 4 times 0 is 0, so negative 5y is going to be equal to negative 10. And then y equal to 2. So we have our ordered pair of 0 and 2. X minus y is going to give us negative 2 for a solution, an answer to this question. All right, let's see what's next. So we have a statement that we're working in the coordinate plane, the xy plane. And we have this equation, y equals hx plus 7. We're told that h is a constant and that the line contains the point AB. And A and B are not both 0. We're told what is the slope of the line in terms of A and B. Well, we know that this is slope-intercept form, y equals mx plus b. So the value of h is going to be our slope. But right now we have this in terms of x and y. We want it in terms of a and b, which this is an x and a y, so we're going to substitute these in. So our y value is b, so b equals h times a plus 7. Now we need to solve this for h because h is our slope number. So we're going to add 7 on both sides and then divide by a. So b plus 7 over a. I'm sorry, I should have subtracted 7. B minus 7 over a. So a great strategy there. When you're working through a problem on your SAT, you get an answer. It's not one of your 4, but it's very similar. That's a good hint just to go back and check your work, and you might find something very simple that you made as an error, as I just did. Let's take a look at number 3. All right. So again, we have a system of equations, 6x minus 7y equals 9, and px minus 5y equals 6. And what we're asked to do in this problem, p is a constant, x and y are variables. For what value of p will the system of equations have no solution? Well, when a system of equations has no solution, that tells us that the two lines are parallel. So when are the slopes of these two lines equal? Because parallel lines have the same slope. So let's go ahead and take our first equation and solve for y. When we put it in slope-intercept form, we'll know what the slope is. All right, so the slope of our first equation is 6 over 7. Now we need to solve our second equation for y. And we find out that our slope of our second equation is p over 5. All right, then. So now our job is to find out when is p over 5 equal to 6 over 7. So now you've got a proportion, which we know in any proportion the cross products are equal. So p times 7 equals 30. And p equals 30 over 7. All right, couple more. So a word problem here. It tells us that there is a law, a rule in science that we can tell temperature by the amount of cricket chirps that are recorded in a certain period of time. And we're given equations for both of those. The number of chirps plus 40 equals the Fahrenheit temperature. The number of chirps divided by 3, then added 4 to that gives us the Celsius temperature. So they give us these two equations, and they give us some information about the number of chirps, and then they give us 3 statements, and we're asked to determine which of these, including possibly more than one, are correct. So to work through this problem, we're going to take the results and work backwards to find the number of chirps. So chirps plus 40 equals the Fahrenheit temperature. And we're told that it was 55 degrees when the scientists took this reading. So solving for number of chirps, we find out that there were 15. Okay, so 15 chirps when it was 55 degrees Fahrenheit. Now, let's take a look at the Celsius reading. Chirps divided by 3, add 4, gives us our Celsius reading, and that reading was 10. Similarly, solving for C. We find out that C is 18. So there were more chirps when it was 10 degrees Celsius than there were at 55 degrees Fahrenheit, which is statement number 1. So we know 1 is true. Let's check number 2. And this is the opposite. More cricket chirps when 55 Fahrenheit than at 10 Celsius, which is not true. Let's take a look at 3 then. If the temperature increases based on these findings, that would mean that the number of cricket chirps increased. And that is true. So number 1 and 3 are correct. All right, one more to look at. So we're given 4 statements, and we're asked which of these statements is equal to 0 for some value of x. Well, each of these has an absolute value. 3 of them have the absolute value result plus 1. One of them has the absolute value result -1, and we're asked which of these can be equal to 0 for some input value of x. Well, what we know about absolute value is it's always either 0 or positive. It's impossible for absolute value to be negative. So having a negative value and adding 1 would get us to 0, but we know that's not possible. And 3 of those involve adding 1. So the only one that is possible is our second option, absolute value of the expression x minus 1 and then -1. All right. See you again next week on the SAT Math Builder.